Okay, guys, so here we go. It is Thursday, okay? So yesterday we had our quiz, the day before we reviewed, and Thursday, all right? So kind of going to totally change gears a little bit, okay? At least for a day, sort of. All right, so here's our objective for the day, that I can identify a function from an ordered pair, table, mapping diagram, or a graph, okay? So go ahead and copy that objective for me. Some of you may like what we're going to do today a little bit better than what we have been doing, and maybe it's a little bit easier. Okay, but let's go ahead and take a look at it. So our objective, I can identify a function from an ordered pair, table, mapping diagram, or a graph. We're going to talk about 3 out of the 4 of those today. We're going to talk about graphing tomorrow, but here we go. All right, so write this definition with me. A function is something that assigns, write this for me, a function it assigns exactly one output to each input. Write that for me. This is what we're going to talk about for the next day or two. What's a function? How do I know what that is? How can I figure out what a function is? So it has one output to each input. Okay, copy that down for me. Okay, so what does it mean? Well, let's take a look at this equation of a line, right? We talked about equations of a line last week, right? And if we have an equation of a line, or actually this week still, but if I have the equation of a line, right, I could make a table with these pairs, x and y. So up here in my definition, we talked about outputs and inputs. Now, if I look at this, you can probably tell me which one's which. So if I go ahead and put, I don't know, let's go with 0. And I plug 0 into my equation, okay? So here's how these look sometimes. We don't do this, but I've done them before in my classes. Okay, and then I'm going to figure out what the y is. So I would do 2 times 0 plus 1. So that means 2 times 0 is 0 plus 1 is 1, right? If I plugged in another number, okay, let's say I just plugged in 1 this time. 2 times 1 plus 1. So there's my function. All right, that's what I'm doing with it. I'm plugging my 1 in, aka the input, right? So you're going to go back up to your definition, add this as my x value. Okay, so then I have 2 times 1, which is 2, plus 1, which is 3. And if I keep going, let's say I do 2. 2 times 2 plus 1. 4 plus 1, 5. You can see that this would be a function because what? If I plug something in, I get something out. If I plug something in, I get something out, okay? And that's what it goes, and there's no repeating, and we're good to go there, okay? Does that kind of make sense a little bit, guys? Hopefully it makes a little bit of sense, okay? So if this one right here was a function, the one that we just did, my x and y, 0, 1, 2, oops, not 2, 1, 3, 2, 5, and this is not a function, okay? Let's say that I have 1, 5, 4, 1, 10, 8, 6, 4. What do you notice about these two? So the one on the left is a function, and the one on the right is not a function. What's the difference? Can anybody tell me? Well, the one thing that is the difference is that look at my x values, okay? When my x values repeat, here and here. So if I plug 1 in, I get a 10, or I can get a 4. If my x repeats, write this for me, x repeats, that means that it's not a function. If my x repeats, that means it's not a function. Write that for me. X repeats, not a function. If all my x's are different, I'm good to go. If all my x's are different, I am good to go. Okay? If I think about this for a second, okay? Okay, so look at that table for me, guys. What do you think about that table? Do I have anything, look at just the x's, do any of my x's repeat? Do any of them repeat? So that makes it a function, right? None of them repeat, so that's a function. What if I have this? What about this table now? Write that for me. I got 6, -8, -4, 6. Look at my ordered pairs there. Look at my x values. Do they repeat? What do you see? Do you see any of them that repeat? Not a function. Okay? Any questions on that? All right. Try these two on your own. Tell me what you think about these two. Okay, pause the video and try those two on your own. Put those two in your notes. Okay? All right, let's try the next one now. Okay, so now let's talk about this table. If I have that ordered pair, all right? If I just look at the last examples that you literally just did on your own, let me copy them real quick. Okay, so if I just look at this table, right? So this is the table that you literally just did on your own. I can tell that these are ordered pairs, right? The x and the y just basically means that they're ordered pairs. Okay? So my ordered pair, 6, -3, 8, -2, 10, -1, 12, 0. Do any of my x's repeat? No, they don't repeat, so that makes it a function. What if I have these ordered pairs? What if I have these my ordered pairs? 6, 2, 5, 1, 6, 4. Okay, does that look like a function? How do I know? Well, same thing as I just did with the table. Do any of my x's repeat? I have a 6, I have a 5, and I have a 6. So that makes it not a function. Okay? Try these on your own. Try these on your own. Here's the first one. I'm going to go with... Okay, you got those two right there. Try those on your own. Try those two on your own. Okay. Last type that we're going to talk about today, and this may be the most confusing one. Okay? But if I look back, okay, we're going to call this next part mapping. All right, and here's the first one. Copy this example with me. It's got two circles like this. 1, 3, 7. And it would have another circle that looks like this. 2, 6, 8. Okay, and then what would happen is I would have arrows that go from which number to which number. So this would be my input over here. This, or my x values, right? This would be my output. Or my y values. Okay, so what does that mean then? So 1, I plug it into my equation, I get 2. 3, plug that into my equation, I get 8. 7, plug that into my equation, I get 6. So if I just read that to myself, 1 goes to 2, 3 goes to 8, 7 goes to 6. Do any of my x's repeat? Nope, which makes it a function. Okay, let's look at another one. What if I do this now? Okay, what do you think about this one? Now, you might be able to look and see and tell me the difference, but look at it. If I read this to you, 3 is my input, 11 is my output. 5 is my input, 12 is my output. 7 is my input, goes to 10 and to 13. If I say the word and, that means it repeats. So that makes it not a function. And the other way that I can prove this to you is if I write these as ordered pairs. 3 goes to 11, 5 goes to 12, 7 goes to 13, and 7 also goes to 10. See how my x's repeat here? Repeat, repeat, not a function. Okay? Try this one out. Try this one out on your own. Here we go. Try these out. Okay, think about my ordered pairs there if you want to. If you want to think about these ordered pairs, you can. Here you go. I got 0, 1. I got 2 that goes to 4. And 2 that also goes to 5. That makes it not a function. What about this last one here? I got 3 that goes to 5. And 3 that goes to 6. And 3 that goes to 7. And 3 that goes to 8. So once again, not a function. Okay? Any questions? If you have questions, guys, now's a great time to ask them in the chat or everything else, okay? We will finish up with that later, okay? We'll finish up with that later. All right, guys. Talk to you soon.